Good, thanks. Well, good afternoon, everybody. My name is Alberto Faronato. I'm Director of Product Marketing for Storage and Availability at VMware. I'm joined here today with my colleague Vijay Ramachandra, Director of Product Management for Storage and Availability, to talk to you about our vision for software-defined storage. I want to apologize for my voice. It's going to be a little bit jumpy. Unfortunately, my 3-year-old son started kindergarten a month ago, and he spread bugs across the house like there's no tomorrow. I'm sure that those of you with kids know what I'm talking about. So sorry about that. But we'll jump straight into it before it's gone. And here's a little bit of an agenda for today. We'll try to keep questions for the end. It's extremely difficult for me to see anything in front of me with the lights, but I'll do my best. If you guys have questions, let's try to do it at the end. In terms of agenda, I'll kick off things and talk a little bit about the overall vision and go over the key product announcements, and then I'll turn it over to Vijay to talk to you a little bit more in depth about some of the key technologies that we're planning to bring to market. So starting from the vision, before I kick off, how many VMware customers do we have in the room? Quite a bit. Good. And how many of you are, also admins, vSphere admins? Pretty much all of them. Do you guys also do storage? Good number. So we've been seeing that for quite some time now. There's increasing convergence in roles and responsibilities, and I guess especially in Europe, where the average company size tends to be a little bit smaller, we see more and more people doing 2 or 3 things at the same time, including networking. And so I'm sure that a lot of the things that we're bringing to market and some of the problems that we want to address will be hopefully resonating with you guys very well. So where do we start from? You've heard a little bit this morning from Pat about the key challenges that we see today in virtual environments with respect to storage. And so starting off, what we hear from customers and we've been noticing over the course of the last 10 years as virtualization became mainstream is that really virtualization changed the storage workload in a number of ways. It's not anymore like it used to be where you had, in the physical world, static applications mapped to physical servers, a handful of objects to manage from a storage standpoint, and a very static mapping of applications to storage as well. Used to be fairly predictable to manage performance with static workloads that wouldn't move too much. And really all the quality of service and service levels were more easily managed through the storage arrays. Now with the proliferation of virtualization combined with the explosive data growth that we're experiencing, shared storage really proliferated and became what it is today, a big component of the infrastructure. In fact, by our estimate, we calculate that roughly half of the infrastructure cost today goes into storage. Virtualization had, as I said, a big impact on storage from a number of standpoints. From a management standpoint, VMs consume storage differently, and they consume it through virtual disks, right? So now you have to deliver all the service levels, not just capacity, but also the service levels that you want for your storage through the VMDKs, mapping the VMDKs to the backend LUNs or mount points. So this creates a number of challenges in terms of being able to place the VMs in the right storage and being able to control the SLAs as the VMs move around the infrastructure, both on the compute side but also on the storage side with things like storage vMotion. The profile of the workload has also changed because now multiple applications are sharing the same compute. The profile of the I/O is much more random than it used to be before. And as you guys know, a random I/O is not really very good for traditional magnetic disks. And so you've seen and noticed the proliferation of higher end tiers of storage based on flash, for example. Managing quality of service is more challenging because instead of having a one-to-one mapping of applications to data stores, you have now multiple applications, multiple VMDKs mapped to the same LUNs. And so as you do this, all the VMs that are mapped to that particular LUN inherit all the advanced data services that you may be assigning to that LUN, things like snapshots, replication, caching, and all this kind of stuff. So there's a lot of decision making that needs to happen and a lot of trade-offs that you need to go through. Virtualization is not the only thing that is really changing the landscape when it comes to storage. There are other important trends in the industry that are happening regardless of what virtualization does. On the application side, as you heard this morning from Pat, it's not just about traditional applications anymore. There's an increasing trend in adoption of this new wave of applications that we call next generation applications, next generation cloud applications that tend to be significantly different from the traditional applications in the data center. From a storage standpoint, they tend to like being scale out in nature. They often leverage direct attached storage. Think of Hadoop, for example. And they are built with specific storage constructs that deliver service levels like availability or performance. Very different from what the traditional applications used to require that were more built around the assumption that the underlying storage infrastructure would deliver the resiliency and the quality of service that the apps needed. On the infrastructure side, there's also increasing diversity, and here there's a number of trends that are happening in the industry. Overall, there's an increasing degree of specialization of storage devices. An important trend that has entered everybody's eyes is the adoption of flash. Right, and this is true both at the storage array side as well as the server side with the emergence of server-side flash. And so pretty much all the arrays today come with a certain capacity of SSDs built in. They're all pretty much hybrid arrays. There's some extreme configurations where also the persistency layer within the array is delivered through SSDs, so you have all SSDs arrays. And we're hearing more and more customers adopting flash also on the server side. How many of you are looking at flash on the server side these days? Yeah, so we're starting to see that very much across the board. Object store and cloud-based storage is emerging. Things like Blob, for example, is a new trend for specific use cases. While it may not be something that is part of an enterprise deployment today, we're seeing an increased adoption also and potentially in the future becoming something that is available for the enterprises too. The last thing that we have in this slide is an interesting trend that we're noticing, which is the birth of what we call the virtual storage arrays. And these are things like HP Store Virtual, or if you're familiar with our vSphere storage appliance, or some of the early versions that EMC is delivering of virtual VNX. ONTAP Edge. These are basically forms of storage arrays that run storage software, the storage controller software, into a virtual machine and run that virtual machine on top of a hypervisor using commodity components in the back end. So fairly nascent thing, but it's something that we think is going to grow going forward. So overall, an increasingly diverse picture, both at the application side as well as the infrastructure side, that makes it much more complicated for customers to figure out what is the right storage for my applications. These are not the only challenges that we hear from customers when it comes to storage, right? And we have several conversations with our customers around this. When we distill down the universe of comments that we hear, there's three key areas that we hear about. In no particular order, first one is management, and there's a number of things that we hear from customers are challenging today when it comes to storage management. Configuring storage, it requires a lot of guesswork. How you set up your boxes, how you assign resources to each individual application. There's a lot of manual processes still involved in managing storage, as well as a lot of silos with each individual storage array coming with its own specific software. We also hear that provisioning in terms of time isn't really aligned with the expectations that are coming from your experience with vSphere, with virtualization in general, cloud, where you can spin up a VM very quickly, but when it comes to assign the storage component to it, now everything slows down and takes much longer. Performance is a second key issue that we hear from customers. In particular, the issue here is around predictability. It's very difficult to understand and predict how the storage array will deliver performance, how well it will perform as the application lives on, both from a stable performance as well as how it reacts to the changes that are happening across the virtual infrastructure. And overall, we hear it's hard today to have an end-to-end visibility process to monitor and troubleshoot. And this really goes down from the fact that you have different constructs that you are managing against from a storage versus a virtualization standpoint, LUNs versus VMDKs. Very difficult to troubleshoot and understand where the problem, which VMDK is creating problem, which LUN is creating problems. Last but not least is cost. This is in part due to the fact that data requirements in terms of capacity are always greater and greater, but it's also due to the fact that in many cases customers have to over-provision for performance. It could be over-provisioning of spindles to get greater IOPS, or over-provisioning of expensive tiers of storage like flash. And this is just trying to address the I/O requirements of their applications and the spiky nature of the virtual infrastructure I/O profile. The management challenges also translate into higher administration costs, if you will. And last but not least, we hear from a lot of our customers, for example, some of you interested in leveraging direct attached storage in the form of flash or HDDs, that's particularly difficult today if you want to also get the benefits of some of the advanced features of virtualization like vMotion and HA. So key questions here is, how do we break down these management silos? How do we help you match the right storage to the application in a much more automated fashion? How do we help you increase efficiency? So we think that VMware is in a position to really help you solve a lot of these challenges for a couple of reasons. The first one is goes down to the fact that vSphere occupies a very important spot in the stack. vSphere is the first layer of software that is sitting between the infrastructure and the applications. And so in this particular spot, we have we can do some very interesting things when it comes to storage, because first of all, we have inherent knowledge about the applications. All the I/O traffic from the application to the underlying storage comes and goes through the hypervisor. And so we have real-time knowledge about what each individual application needs. The hypervisor is also a hardware-agnostic component of the infrastructure, really plays across the board, and has a global view of the infrastructure because it integrates directly with all the different storage arrays through a number of API constructs that we're working with our partners. And so we feel that leveraging the hypervisor can be an important way for us to open up new opportunities to solve the complexity of the underlying infrastructure. The second reason that makes us believe that we can help is that VMware has a strong expertise and knowledge of storage. You may not think of VMware as a storage company, but in reality, throughout the years, having to work on the hypervisor, we also had to develop deep understanding of the storage infrastructure. And so if you look at vSphere today, you'll see that there are a number of technologies and features that you already have access to that are really storage focused and storage specific. Think of VMFS as a starting point, but also the advanced APIs that were introduced over the course of the years, the array integration APIs, the storage awareness API for integration with storage arrays, features like storage vMotion or storage DRS, advanced data services like vSphere replication or vSphere data protection. These are all the results of big investments that as a company we've made in the area of storage. Now, clearly this is not enough. It's a starting point, and we want to take it to the next level of automation and next level of efficiency, and this is really where our vision for software-defined storage goes. So what is software-defined storage? Software-defined storage at the high level has the objective of delivering the same efficient operational model that you can leverage today to manage your server infrastructure through vSphere at the storage level. It's a key component of our old vision for the software-defined data center, and it's really about two key things. It's about abstracting the heterogeneous resources, storage resources, and presenting them in terms of large capacity pools that can be logical capacity pools that can be flexibly consumed by VMs. And the second part is really about enabling a new model for managing SLAs, a model that is based on an application-centric, policy-driven control plane, which we're going to talk about in a second. So let's dig a little deeper and understand the high-level concepts. We'll then go back and see the actual technologies in greater detail with VJ. Now, so if you think about it today, when you have to assign storage resources to your applications, there's a number of interactions that happen, right? Typically, the VI admin goes to the storage admin. In some cases, it's you're talking to yourself. And what you have to figure out is what the application requirements and how do I provision against in terms of service levels, capacity from the underlying infrastructure. Typically, if an application is a tier 2, tier 3 application, you eventually put it on a share of the file system with other applications. If it's a mission critical application, chances are you're going to give it dedicated resources, which means that more often than not, you'll have to do some back-end envelope calculations about determining which spindles to allocate, how much IOPS out of the inventory that is available in your data center, how to make sure that those IOPS will be available to the VM. And it also means that you're going to have to think about how to configure and deliver data services. And these data services, things like RAID levels or replication or caching, they tend to be today very focused on being delivered through a device-centric approach, right? Everything is controlled and managed through the storage array itself. And this creates a significant inefficiencies in terms of being able to quickly respond to the provisioning requirements of the application as well as the ongoing management of your applications. Think about doing all your calculations, provisioning storage, and then all of a sudden you find that things are not working. You have to reconfigure things, which that often happens and requires you to go back and migrate data to a different location with different setups. So fundamentally here, we're facing the challenge that goes down to the fact that storage and storage services are provisioned and delivered to the VMs from a very device-centric model. And this is really the first thing that we want to change. And we want to change it for what we call a policy-driven control plane. And the policy-driven control plane is really about starting from the virtual machine. The virtual machine encapsulates the application, and this is where your storage requirements should be defined and should be executed against. So what we want to enable with this policy-driven control plane is a couple of things. First of all, we want to give you the ability to define VM storage policies, which is nothing else but a set of attributes that capture the requirements of your application when it comes to storage. So things like capacity, what kind of performance you need, what type of availability, whether it's in terms of RAID levels or in terms of replication and data services, whether you want to have something leveraging caching or not for increasing performance. So capturing the profile of the VM, associating this profile to the VM, and have this policy follow the VM across the infrastructure regardless where it is. The second aspect is building an intelligence engine that will allow you to do a few things. First of all, automated provisioning of the data services that are necessary to fulfill the policy, right? If you specify that you want something replicated synchronously, the infrastructure, reacts and provisions the right level of services, but also, interpret the policies and make the right level of recommendations in terms of where to place it, on which tier to place the VMDK in order to get the type of service levels that you specify. And doing this on an ongoing basis, so as the conditions of your infrastructure change, as you load more VMs or some components of the infrastructure fail, you can react to it and continue to deliver the type of service levels that your policy specifies. Now, in order to do this, there's a second component of our strategy that we need to enable, which is this ability to provision and manage data services at a VM level. As we said a couple of minutes ago, today, most of the data services, things such as caching, replication, and others, are all managed and delivered through LUNs or mount point, and they're really not VM-centric in terms of granularity of management and awareness. And so what we want to do is to enable a broad ecosystem of partner-delivered as well as VMware-delivered data services that integrate with the hypervisor and allow you to provision and manage data services from a VM-centric model. This is really a fundamental component that really rounds up the provisioning mechanism that we talked about through the policy-driven control plane. The last element of our strategy is the virtual data plane. The virtual data plane is really about abstraction and pooling. And as we said, the diversity of devices in the infrastructure is growing. And so in order for us to enable efficient consumption of storage resources, we have to focus on being able to pool and abstract these underlying devices. The second aspect of the virtual data plane that is extremely important is really enable a VM-centric operational model for storage consumption, as well as enable the hypervisor through a set of APIs to be aware of the underlying capabilities of each individual device in your infrastructure. And this is a key second component of the equation of the policy-driven equation, because, as we said, the policy-driven engine need to be able to determine which components in the infrastructure, which pools in the infrastructure can deliver the type of service levels that you require for that VM. Now, when you look at at the virtual data plane and the infrastructure in general, we see two key pools of infrastructure building the storage infrastructure going forward. Number one is the external storage pool. This is really what you guys are very well familiar with today. And we feel and think that external storage will continue to be a key element and a key way to deliver storage. It's most likely going to be continue to account for the majority of the capacity in the data center, is where most of the data will live going forward. It will continue to evolve, in terms of delivering increasing scale, new forms of storage, and richer data services. We are working, and we plan to work with our partner ecosystem to build the right APIs and integration points to be able to offer higher level abstraction abstractions and higher level integrations with the hypervisor. And Vijay is going to talk to you about some of the technologies in that area, like virtual volumes. The second key tier or pool of capacity that we see emerging in the data center is what we call converged infrastructure. And this is something that we're looking at enabling more effectively ourselves directly with a number of technologies, first and foremost virtual SAN that you heard about earlier today. This is about delivering storage and compute together, and so converging, extending the hypervisor to be able to pool both capacity, both compute as well as storage capacity to deliver a scale-out, converged storage plus compute infrastructure. We feel that for some of the use cases that are emerging in the data center, like VDI, for example, this is a great way to deliver storage services. Now, summarizing, just in terms of wrapping the whole vision together, as we said, 3 components: policy-driven control plane for heterogeneous automation, policy-driven across all forms of storage; virtual data plane to abstract and pool underlying resources and expose the capabilities of underlying systems into the hypervisor; and application-centric data services for granular VM-centric provisioning of data services. All of this would not happen if it were not for a very strong collaboration with all our partner ecosystem. We're working across all these initiatives and in a number of technology areas with all our server and storage, as well as availability partners. And so you'll hear a lot of announcements around things that we're doing with them across the board, and we plan to continue to work with them to make this vision a reality. Quick summary of the key announcements that we've made since VMworld US and that we reiterated this morning during Pat's keynote. First, in the area of converged infrastructure, we recently announced the public beta of virtual SAN. This is a breakthrough technology that Vijay will go through in details in a second that really allows you to, for the first time, deliver software-defined storage leveraging locally attached disks that also give you converged infrastructure. In the area of external storage, we continue to talk about virtual volumes, and in particular at VMworld this year we're showing tech previews and several partner demos of implementation of this important integration point with our partner ecosystem that delivers VM-centric, VM-aware external storage arrays. In the area of application-centric data services, a few things that we've announced are vSphere Flash Read Cache. This is a feature that is available today with vSphere 5.5. It delivers performance and storage acceleration through read caching that is delivered through server-side flash devices. It's really an important technology for if you're interested in accelerating the performance of your applications by leveraging server-side flash without the need of agents and from a VM-centric consumption model of your flash resources. So you can assign flash on an individual basis to each VM. The last one on this slide is Versto. Versto is a result of an acquisition that we completed in Q1. It is a software-based solution that allows you to solve the problem of the I/O blender with a log-based architecture that sequentializes writes to disk, making writes to disk much more efficient. Versto runs as a software component, leveraging external devices, so it's leveraging block storage. So it's a very simple and easy way to address some of the performance problems that you may have in your environment. And it's already now available. At this point, I'll turn it over to Vijay to go over the details of some of the technologies that we just talked about. Can you hear me? All right.
So Alberto talked about VMware's vision to deliver a software-defined storage infrastructure. What I'm going to be doing is going over some of the products that speak to that vision. Now, I do want to point out that I'm going to give an overview of some of these products. We do have deep dives, technical deep dive for each of these products and more in other talks, in other sessions. In fact, there is a Virtualization session right after this in the same room that Christos is going to give. So I'm going to give an overview to paint the picture of how we're delivering all this software-defined storage magic. And for the deep dives, please attend those, those specific sessions. All right, so the first product that I'm going to be talking about is Virtualization or vSAN. So Alberto talked about converged infrastructure as being one of the critical components of our software-defined storage vision. vSAN is our first foray into delivering a software-defined a software-defined storage, or realizing a software-defined storage vision, and it enables the creation of a converged infrastructure solution. Okay, so what is vSAN? vSAN is a scale-out storage system that's built into the hypervisor, and the idea of vSAN is that it clusters locally attached or ESX attached storage devices, hard drives, and SSDs. Pulls them together into a pool of storage to store VMs on. And the important thing about the pool of storage is that it looks and feels like a shared storage system. It exhibits all the behavior of a shared storage system, although it's made up of local disks, and it's flash optimized from ground up. And more importantly, vSAN is a software-only solution, and it uses industry standard components, as you can imagine, because it's built into the hypervisor. And the big value that we want to provide with vSAN is around management. So vSAN is built from ground up around the notion of a policy-driven storage management approach. I'll talk about that aspect in a second, but before I do that, let me first talk through some of the salient features of vSAN. All right. So some of the key features of vSAN. First off, vSAN is a scale-out storage system. So what that means is that both capacity and performance can be scaled in vSAN by adding more nodes to the vSAN cluster. Okay. The second property of vSAN, or the second most important feature of vSAN, and as I mentioned this earlier, is that although vSAN uses ESX attached or vSphere attached, locally attached hard drives and SSDs, to the end user, it looks and feels like a shared storage system. So VM mobility features such as vMotion, DRS, and SDRS work as is in a vSAN environment. The third important aspect of vSAN is that it's flash optimized. So we use flash optimally, SSDs or PCIe flash optimally as both a read cache and a write buffer. And as you would come to expect from any enterprise class storage system, vSAN is highly resilient, and there are no single points of failures, and we have implemented a distributed RAID mechanism for resiliency as well. And again, if you attend the vSAN deep dive session, you'll learn more about how we've implemented this under the covers. And the fourth important property of vSAN, as I mentioned earlier, is around its management, how easy it is to manage vSAN. So vSAN, we built vSAN from ground up around the notion of a policy-driven storage management approach. What that means is that vSAN, you tell vSAN what a VM or an application requires when you provision an application on vSAN, and vSAN under the covers will ensure that those requirements are met automatically. Okay, and I'll talk about that in a second. So those are the key salient features of vSAN, and the next thing that I want to talk about is how we've implemented a policy-driven approach to storage management with vSAN. So before I do that, let me just talk about what we have done so far with policy-driven storage management. we do have a feature in vSphere called profile-driven storage management. How many of you have heard of that feature? Just two, and it's not surprising because profile-driven storage management does have its own limitations, which I'll talk about now. So with profile-driven storage management, what we allow you to do, and which is available today, is to bucket data stores into tiers. So you can bucket data stores into gold, silver, bronze type tiers. And when you provision a VM, we allow you to pick a profile for the VM, again, profiles such as gold, silver, bronze, and so on. And when the VM is provisioned on the data store, we match the profile against the data store, against the tier. So a gold VM with a gold profile gets provisioned on a gold data store. And this is simplified to for a lot of customers, this is simplified storage management to a great extent, but this has one key limitation. And the key limitation is that it's not granular enough. So we don't allow you, with this approach, we don't allow you to specify what each VM requires. So it's sort of a coarse-grained way to manage storage management or VMs. And so, and this can be a major limitation because each VM in your virtual environment could have its own set of requirements, which is not exploited with this approach. So we've changed all this with vSAN. With vSAN, we moved from a profile-driven storage management approach to a policy-driven storage management approach. And with policy-driven storage management, we allow you to create policies when you provision a VM on vSAN. And these policies essentially encapsulate the requirements of the VM. And the requirements could be availability requirements, performance requirements, and so on, capacity, and so on. And when you create a VM, you create these policies, you attach the policy to a VM when you provision the VM on vSAN, and essentially those policies then get transmitted to virtual SAN, the system, and vSAN takes those policies and enforces it for you automatically. So throughout the life cycle of the VM, those policies are guaranteed to be enforced by vSAN. And this greatly simplifies your SLA management. This is the first step towards automating SLAs on a per application or on a per VM basis. So again, with vSAN, we moved from a profile-driven, coarse-grained control to a more granular VM-centric approach to storage management. All right, I have a few screenshots that show that this is not, we're just not talking about the slides, and this is actually reality. So the screenshot shows how you turn on vSAN. Essentially, it's a single button, and if you know how to turn on enable DRS or vSphere HA, vSAN is exactly the same thing. When you go into vCenter, there's a button that says turn on vSAN, and you have a storage system. Okay. What this shows is that this is a data store. Again, it looks and feels, as I said earlier, as any other data store, a shared storage data store, except it's made up of locally attached disks and SSDs. And here's an example of a policy being created for a VM, and vSAN has a number of properties or capabilities that you can define on a per VM basis. Some of the things that we allow you to specify are your availability requirements, how many node failures you want to protect against, how much cache you want to reserve for your VM, which translates to how much performance you want for the VM, and so on. And once you set those capabilities, or once you set those requirements on a per VM basis, these policies, as I said, gets relayed down to the vSAN system, which will then automatically enforce it for you. So just to summarize what vSAN uniquely brings to the table, first off, vSAN is native to ESX. It is not a virtual appliance. It's built into the hypervisor. It's native to ESX. And what this allows us to do is it allows us to manage internal resources most efficiently. And more importantly, it allows us to minimize the I/O latency, end-to-end I/O latency, because it's built into the kernel, into the hypervisor. I talked about policy-based management or per VM-based policy-based management. We not only allow you to specify policies on a per VM basis, but also vSAN from the system, at the guts of the system, it's built around per VM data operations. So everything in vSAN is built around the notion of per VM data operations. So things like data services and so on, and data operations, so on, is all done at the per VM level. I already talked about policy-driven management, but again, I want to reiterate this greatly simplifies how you manage storage with vSAN. And last, vSAN being built into the kernel, it seamlessly integrates with every feature in vSphere, so it's well integrated with vSphere as a whole. So things like DRS and cluster resource management is well integrated with vSAN because of it being in the kernel. So net, vSAN is an enterprise storage system that radically simplifies how you manage storage, and it delivers the lowest TCO for storage without any performance compromises. And if you compare vSAN to the rest of the industry, vSAN performs at, or the way vSAN is will be positioned is that it performs around, it performs like a mid-range storage, external storage system, SAN or NAS, except it comes at a much lower price point because of utilizing local disks. And speaking of performance, here is a chart that compares vSAN's performance to an all SSD external storage system for VDI. And what this chart shows you is that the number of VMs that can be supported on vSAN compared to an all SSD or an all flash storage external storage system is exactly the same. In other words, the VM density, VM VDI density, or number of VMs per cluster is exactly the same, which speaks to the performance that vSAN can deliver. However, the price point that vSAN comes in is at 25% off the cost of an all-flash storage system. So, same performance for VDI at 25% of the cost. That's what this chart is showing. And also, and more importantly, specifically for VDI, because vSAN can scale linearly in terms of performance, you no longer have these huge upfront investment as you scale your VDI. So what this chart shows is that as you scale your VDI from 500 VMs to 1,000 VMs and so on, the upfront investment that you have to make on storage with vSAN is granular, it's smaller, and it's steady because vSAN's performance scales linearly as you add more nodes. With an external storage system, you have this huge upfront investment that you have to make every time you scale your VDI deployment. And that's what these spikes show you. So compared to an external storage system, VDI is a much more efficient way to manage storage. And this one is just showing an example of what that would be in terms of cost in a VDI situation. So as Alberto mentioned, vSAN was announced as a beta product, public beta product with VMworld San Francisco, and it's available right now to be downloaded. It's free. Take a look at it and play with it. Okay, so and also there are a couple of deep dive sessions. There's one on vSAN architecture, which is going to be right after this session at 3:30, I believe. And there's also a vSAN best practices session, I believe, later today at 5 o'clock. All right, so I covered vSAN at a high level. The next one, the next product that I want to talk about is virtual volumes. So what I want to bring the same, with virtual volumes, I want to bring the same ease of management that I just talked about with vSAN, the policy-driven approach to storage management to external storage. And, I'm sorry. So the goal of virtual volumes is to be able to do the, to be able to provide the same ease of management, policy-driven approach to storage management for external storage systems, as I talked about with vSAN. So what I want to be able to do is create policies on a per VM basis and do the same things that I did with vSAN, except in this case, I have an external storage system, your SAN or NAS storage system. And to do this, the only way to do this is to move from a model where your VMs are placed on these coarse-grained LUNs and volumes to a model where VMDKs are native objects of an external storage system. And this is exactly what virtual volumes is. Virtual volumes allows you to move from a model where you're placing VMDKs on LUNs to a model where VMDKs are in fact native objects on your external storage system. And what this allows you to do is utilize and make use of data services that are available on external storage systems. So things like replication, snapshots, caching, encryption, deduplication, and so on can now be enforced and executed on external storage systems on a per VM or per VMDK basis. So virtual volumes, virtual volumes is a set of APIs and a complete solution that allows you to do that. It converts your existing SAN or NAS storage system into a system that recognizes VMs and VMDKs and is able to perform these data operations natively on a SAN or NAS system. And the value that it brings to the table is that the data operations such as snapshots, replication can now be performed at a VM granularity as opposed to a LUN or a volume or a mount point granularity. And a couple of screenshots to show that to show how virtual volumes work. What I'm showing here is that the same the same policies that I showed you earlier, the same way to create policies can be done with virtual volumes, except in this case, these policies get encapsulated into these profiles, which are then sent down. Instead of vSAN, it gets sent down to an external storage system, which will then enforce these policies for you. And we have been working for a couple of years, and couple of years on virtual volumes. We have broad industry support for virtual volumes. All these partners are behind virtual volumes and are going to deliver storage systems and firmware that support virtual volumes. And in fact, a lot of them today at this VMworld have demos in their booths that showcase vVols. How many of you have heard of vVols before, virtual volumes before? Okay. All right. The last part that I'm going to talk about is Versto. Alberto talked about data services, application level data services as being one of the important components of the software-defined storage vision. Versto is a product that delivers data services, again, at the VM or VMDK granularity. And what Versto is it's a software solution that sits behind, that's delivered as a virtual appliance, in a virtual appliance form factor. It sits behind a block device, a SAN external storage system. It consumes LUNs and improves its performance. It delivers higher performance and it delivers more predictable performance seamlessly as a software solution on vSphere. And the magic behind Versto is that it takes random IOs, which are typical in a virtualized environment, and converts them into sequential IOs. And that's number one. Secondly, the Versto file system, if you will, or the data on disk format that Versto that Versto delivers provides high performance snapshots and clones. So Versto again is a software solution that's delivered as a virtual appliance, sits behind a block device, and it improves its performance, number one, and secondly, it delivers high performance snapshots and clones at a per VM or per VMDK granularity. The value of Versto is that because it improves performance and delivers predictable performance, it lowers the cost of SAN. And because it's per VM based, it improves the time to provision your storage. And so you get overall better SAN, better bang for the buck, if you will, for your SAN systems. And here's the performance, a chart that shows, that compares performance of a MS SQL deployment when you have Versto and when you don't have Versto in your environment. And what this shows is that with Versto in the picture, your MS SQL application, the performance that you can get from the MS SQL application improves by 110%, and you're essentially more IOPS, both read and write IOPS, as well as lower latency, overall latency in your MS SQL appliance application. And here's a chart that shows that with Versto, taking the number of snapshots that you have in your system has no bearing on how your VM performs. So no matter how many snapshots you have in your system with Versto, because of the way the Versto file system works, your performance remains steady as you take more and more snapshots and clones. So I'm going to close this out by summarizing our approach to software-defined storage. And again, there are three main components of our software-defined storage vision: a virtualized data plane that lets you abstract and pool storage devices both locally and externally, and a control plane that lets you automate SLA management across your VMs, and finally app-centric data services that can be executed either on an external storage system with vWalls or on vSphere through partner solutions. So that's the presentation today. And again, these are the products that we are announcing with this VMworld. I think we have some time for Q&A.
Yep.
Yeah. Yep.
Several presentations I see with the Duke on it. So that's several storage presentations I see this year with the Duke on the slides.
Yeah.
You don't necessarily speak about it, so any...
Dedupe?
Yeah.
Yeah, so with respect to vSAN or in general?
But I mean, storage-wise, I mean, in the hypervisor, are you bringing some dedupe?
Right, so dedupe is something that we are looking at, but it's not in the roadmap yet, so I cannot speak, I cannot speak to it yet. Any other question?
Down there. Yep.
Oh, sorry, go ahead.
One of your slides showed about Versto, a reduction in the number of gigabytes. How does that work?
With Versto?
Yeah, with Versto.
Yeah, so a couple of ways. One is when you're using Versto's cloning technology for fast provisioning of VMs, it's a space-optimized implementation of clones. So you reduce the number of your total capacity through these clones, but you don't suffer the same performance degradation as you would with the existing cloning technology. So Versto provides you high-performance clones, and hence increasing capacity. Yep. Any other questions? Yep, go ahead.
Does it need a dedicated 10 gig network?
vSAN does not the recommendation is to have a dedicated 10 gig network for vSAN. It completely depends on the application that you're running on vSAN. The recommendation is 10 gig network, but we will support a 1 gig network as well with vSAN.
Separate from the vMotion network?
Separate from the vMotion network.
But you can share, right, the backend?
So the same network.
But the recommendation is...
So we're going to over-provision the networks?
No, I mean, it's only 2 cards, right?
Why would you over-provision the network?
I'm not going to be doing vMotion all the time. I'm going to have a vMotion network. I'm going to have a vSAN network. I'm going to have a bunch of separate networks for all these things I'm going to do.
Yeah, so these are virtual networks. So Okay, so the question is
physical network.
whether vSAN is going to over-provision network because you have a dedicated 10 gig network for vSAN, a network for vMotion, and so on. So these are virtual networks, so it's not physical network, and the same physical link can be shared across all these across all these functions. And as I said, the recommendation is for 10 gig. It depends on what the application requires, and based on the application, you may need to have you may need to dedicate the entire 10 gig network for vSAN, but it's not a requirement for vSAN.
Question there?
Yeah.
What is the level of resiliency in the case of the virtual SAN solution? The number of ESX servers which can go down without the new virtual SAN file system going down?
Okay, so with vSAN?
Yes.
So vSAN can tolerate up to 2 node failures at any one point. I know.
Depending on the policy you have.
Sure. So, hello? All right, it's okay. Any other questions? Yeah.
Question?
Will you go through this deeper and the other sensors?
Yes.
Yeah.
Yes.
All right. We'll stick around if you have more questions, but thanks.